Hi, it's Richard from Intelligent Advisor IT Consulting again with another in our series about the example projects. I've said this 1,000 times, I'll do it one more time and say that the example projects can be found on the project tab and they can be found under example projects. And today we're going to be looking at retail discounts. Now, retail discounts, as you can imagine, is from the retail field. So if you've ever been shopping and had a discount because you're a loyal customer, then you'll know what this is about. This is one of the best known and most loved example projects for people who are learning about entities and relationships and specifically how to infer entities and perform and use functions like infer instance for. So it's a great place to come if you have a question in your mind about that, because everybody understands the business scenario. If you're a loyal customer, you get a discount. So we'll be talking about inferred entities, we'll be talking about rules to do that. We'll also be talking about temporal data, so it's one of the first times we've seen a temporal logic in an example. And this project rounds itself out by having a bunch of test cases to allow you to test your project as well. So let's go and take a little step into the data tab, because clearly we need to set the scenario. You have orders, and you have previous order, and you have an updated order. So you need to know how these three fit together. So you as a loyal customer, you come to our shop and you make an order. You have previous orders. That's your history with us. And based on your previous orders, if you've been a good customer and you've purchased some things, we will then update your order and give you an updated order which has discounts in it. So you create an order, we look at your previous orders, we create an updated order. And allied to that is the concept of a brand. The discounts we're going to give you are based on you buying products of brands. So you maybe buy 5 different products, of which 3 belong to a specific brand. Okay, so now we know the basics. You'll notice that updated order and updated order line, as well as the brand, these are all inferred entities. So they are not entered by an end user, they are defined in rules. The order and the order line and the previous order, this is ordinary data. This is not defined by a rule. This is either entered by a user in the system, or we're reading your previous order history, perhaps from an external application. At least that's the sort of imaginary scenario that we have. In the interview, therefore, we have some very simple ideas. We want to know if you're a gold member or a silver member in our loyalty club, because that might affect the discount that we give you. We want to know about the order that you're creating today. We want to know about the details of that order. So what are you buying today? Then we want to talk about your previous orders, because we want to find out whether your previous orders are good examples of your loyalty. Have you spent at least $300 in the last 12 months? And to do that, we look at your previous orders. Finally, we look at things that have been removed from the order. So there may be things that are not eligible or shouldn't be included in the final order. And we will finally tell you about the new updated order. So we've maybe given you a discount. So let's walk through this. Before we look at the rules, let's just walk through this from an end user perspective. Okay. There we go. And I'm in the debugger now, and I will start and I'll say, okay, well, I'm a gold membership level, and I'm making an order today, and this is my address, and this is my order. I'm ordering 100 facial tissues and another 100 facial tissues. I'll add one more thing. I'll add a different brand. I'm going to order a cosmetic cream. I'll order 50 of them, and the unit price is $2. Fine. So that's my order details for today. And we want to know about your previous orders. So in this case, we're simulating having them come from an external system, whatever it is, and saying these are your previous orders. And we'll say that you ordered one on the 26th of September this year and another one on the 10th of September. So you have a pretty big, you've racked up $1,000 already with us. So now we need to know that, okay, you should have paid $304. You should pay $304 because We've given you $76 in loyalty bonus based on whether you're a gold or a silver, and we've given you $120 in brand discounts. So in this case, I've won twice. I was a gold customer, so I get a loyalty bonus, and I've made purchases for a specific brand, so I get a discount. So let's understand about this. So basically, what we're saying is we've created a discount for you of $76 because your order that you created, you're going to take the original number and say, okay, you get a discount percentage. Okay, you get 20% discount, and okay, that means because you spent at least $800 in the 365 days prior to order one, and we gave you free shipping because you're a customer who is gold and your order is over $100. Let's dig into the details of how that works. So let's take a look at your order. So there's your order, the one that we just made, and there is the details. These are the 3 items that I entered on my order. We can see over in the brands, it has detected that there are 2 brands in here, Soft Stuff and Test Brand. So it's understood that there are 2 brands, and it has accumulated or totaled rather, the total in my order per brand. So I'm spending $400 in Soft Stuff, and I'm spending $100 in Test Brand. And you can see that Soft Stuff has given me a discount percentage of 30. So the amount of money I spent on this brand has given me a discount of 30. In addition, you may recall I had previous orders, and the previous order total, I have an order on the 26th of September and an order on the 10th of September, both of which were for $500, so I've already spent $1,000. And we can see that I'm a gold member, I'm eligible for free shipping, and the total I saved in brand discounts today is 120. And we can go and have a look at that because the total saved in brand discounts instant sum, the updated order line items, the updated order line item discount. So we can go and look at our updated order, and you'll notice that the updated order is essentially a clone of my order today. But when we look at my updated order and we look at it, we'll see that I'm actually paying not $200, which was the original order. So if I go back to the original, you see I was ready to pay $200, but it's applied a discount to ensure that I only pay $140, because you may recall there was a 30% discount. Same for the second line, because that was also facial tissues. But on the third line, I have a net price of $100, and I don't have any brand discount on this, because I only spent $100. So it's leveraging the fact that it's created a clone of the original order, but it has applied a discount to the updated order. It did that by, on the original order, calculating a discount percentage on the original order. It's not applied here, it's just calculated, and then it's applied on the clone. So this introduces a couple of really interesting ideas. It's the ability to clone entity instances, and then based on whatever data is on the source of the clone, we can apply that to the target of the clone. So here, in the source of the clone, there was a 30% discount was created, but it wasn't applied. It was applied on the clone. So let's see how all that works in terms of rules. If I go into let's go into the data tab and look in the updated order, right click, and you'll see that the first part for creating the clone is really very simple. When you create a clone, you're using a function called infer_instance_for. And when we look at our Word file, there we go. It's one simple straight line. It says the updated order exists for the updated order's original order. So this is a relationship. And when we look at this relationship, it won't surprise you that this is a relationship that is essentially saying, okay, the order is the original order and the updated order is what I'm creating. So you're creating a clone of the order and you're calling it the updated order. The second part is the updated order line items, because you remember that an order has line items. So it uses the same function again. So this is infer_instance_for. It applies the same logic and says the line item on the clone comes from an original line item. And it then has a for scope. For scope is important because if you create multiple orders in this particular project, you might find that when you create, for example, one order with 2 lines and another order with 2 lines, that without this line here, you create you create 2 clones, so you clone both orders, but both orders contain all of the lines. So you need to explain to Oracle Intelligent Advisor that when we clone an order, make sure that you only bring across the line items that belong to that order. So the for scope says, okay, this is talking about the line items order. So if we go back to line item and order, so it's basically saying when you're cloning an order line item and you're cloning an order to create an updated order and an updated order line item, make sure that when you clone them, the line items that get cloned are only the line items for each order. So what it basically means is, from a debug perspective, if I go to my orders here, you see I have one order. Let's add another order. So these are the original orders. We'll call this, let's say, and we'll say, so we're delivering this, and we'll add one line item. So I'm doing this the manual way. So I'll say the order line item quantity is 100. The unit price is $2. The brand is, let's call the brand, what did we call it? I can't remember what the brand was called. Hold on. Soft Stuff. Let's use the Soft Stuff brand. Okay, Soft Stuff brand. And the product, little facial tissues. So I'm ordering more of those. So I now have 2 orders. Okay, so I have order 1 on the 10th and order 1. So I have 1 on 2020 and 1 in 2022. So when I look at the updated orders, as you'd expect, I have one updated order which has only 1 line item, which is the clone of this one. And then I have one updated order which has 3 line items, which is clone of that one. So the clone has been successful. The clone being successful is in part down to this section here, because if I don't make Oracle Intelligent Advisor understand that you don't clone every item into every order, you could end up with something a little, I pull that out, and let's go back into my debugger. And so I have my order. I have my orders here with 3 lines on this one and 1 line on this line, on this one. When I look at my orders, you'll notice that they both have 4 lines, which is clearly wrong. These clones shouldn't have 4 lines. One of them should have 3 lines and one of them should have 1 line. This is a very common scenario. If you've ever done any in-fair instance 4s, you've probably come across this. So you would need to make sure that you have this extra item in here, which says basically, in the context of the line items order, so the original order's line items, make sure that when you're cloning, that you're cloning the right lines for the right order. So the order must be a member of the updated order's original order, which means when you're cloning lines, make sure that the updated order is tied to an original order so that you don't end up cloning everything. So if I now put this back again, we should see that everything's come back to normal now. We have 3 lines in one and 1 line in the other, precisely because we said make sure that you clone according to the original order so that the original line items go to the cloned line items for the original order's cloned order. And then we had this thing about some line items should not be included in the final order. Basically, if you order something that has a value of 0 or less than 0, then we don't clone it. Simple as that. So you might be getting something for free, but we don't consider that as being part of our calculation. And the brand, incidentally, uses in-fair instance, so it creates a single entity instance for each brand. So this is a very famous scenario. So if you come here looking for instance for information, the key thing is here, when you have this kind of structure, you'll probably end up using a scoping function to make sure that when you clone stuff, you don't clone everything that's a child into every parent. You only clone the children that belong to a particular parent into the clone of the parent so that you have the matching structure. If any of you have ever attended any of our training courses, you'll be familiar with the concept of the garage, the repair shop, and the cars and the wheels. This is a classic example of how to build an infer instance structure for cloning entities. What else do we have in this project? Well, we have a whole bunch of rules. We have some business rules, clearly. We need to make the calculations about the order. So this is to do with calculating the amounts payable, the customer loyalty discount, the line items. None of this should come as a big shock. And then you have the previous spend, and you might notice that we have a function called interval daily sum. Interval daily sum, the keyword interval tells you that this is a temporal piece of data. So the amount you spent in the last 365 days, of course, is changing over time. So if I take a look at this particular attribute here, the total of all previous orders on the day, so this is a temporal view of the total of all previous orders on the day. That's the first time we've seen temporal in here. So the amount spent in the 365 days prior to the order is an interesting one, because clearly if your order is dated today, then we need to look 365 days in the past to find the amount spent in those 365 days. But if you make another order that was 10 days ago, then the 365 days, so the 365 days concept requires a particular function, interval daily sum. So if we take a look at interval daily sum, let's go and have a look at it. We're doing it the old-fashioned way, and you'll see that it talks about temporal reasoning. Interval daily sum is a temporal function. So it calculates the sum of a non-Boolean attribute in a time period. So if you're interested in temporal reasoning, then I strongly recommend that you take a look at our temporal reasoning training. Otherwise, as far as temporal reasoning is concerned, you can understand that the date 365 days before the order date is a sliding date. It depends on when you made your order. It's not a fixed date 365 days in the past. It's a date that depends on the order date. So when we calculate the amount spent in the 365 days prior to the order, we have to be able to think about, well, what's the date 365 days before the order date? And what was the total of all previous orders on the day? Because the total of previous orders on the day will give us the amount that you spent in previous orders prior to that order date. So the total of all previous orders on the day is actually a temporal attribute. So it has a value that changes over time. What else do we need to look at in this project? Well, we have rules that we've seen about brand discounts and customer loyalty, some error and warnings, so that if you've not done any error messages before, you'll be able to use the error warning. So please enter a price greater than 0. Previous orders must have occurred on or before the current date to stop you trying to enter a previous order that's in the future, that sort of stuff. And these are both showstopper errors. And we have some validations for the order line items. And you may remember we talked about this a minute ago, that an order line item that has a quantity of less than 0 shouldn't be included in the final order. If you've ordered 0 of something, then there's no point in us including that in the clone. And there's a Boolean to tell us if the order has had items removed. And there you go. So the reason for removing the order line item is perhaps because you entered 0 quantity available. And if you chose a particular brand, then you get a warning, you get an output to tell you that the brand is unavailable because it's yesterday's brand. Get it? So that just about wraps it up for this extremely interesting project. It's one of those ones that if you started working with entities and inferring entity instances, you're bound to come here. So take your time, and if you have questions, just drop them in the comments of this article or in the comments of